Good day, everyone. I am Crizel Silaranang from ECEA 103B15. So, the assigned topic to me is photovoltaics. Hi, everyone. So, let's get started. Photovoltaics is the direct conversion of light into electricity at the atomic level, the production of electric current at the junction of two substances exposed to light. So, it is also a renewable source of energy. So are you guys familiar with calculators that has a set of solar panels built into it? Even so, these calculators usually come with a battery inside that actually powers the device. These panels help to extend the life of the calculator by slowly recharging the original battery. Some materials exhibit a property known as the photoelectric effect. So, this is where it causes them to absorb the photons of light, so from the light rays, and release electrons. And when these electrons are captured, an electric current results that can be used as electricity. So let's talk about the short background of the photoelectric effect. It was first noted by a French physicist, Edmond Becquerel, in 1839. He found that certain materials would produce small amounts of electric current when exposed to light. In 1905, Albert Einstein described the nature of light and the photoelectric effect on which photovoltaic technology is based, for which he later won a Nobel Prize in Physics. The first photovoltaic module was built by Bell Laboratories in 1954. It was built as a solar battery and was mostly just a curiosity as it was too expensive to gain widespread use. In the 1960s, the space industry began to make the first serious use of the technology to provide power aboard spacecraft. So, solar panels were able to help astronauts as they began exploration. And during the energy crisis in the 1970s, photovoltaic technology gained recognition as a source of power for non space applications. Now let's talk about the principle of operation inside a photovoltaic cell. This diagram illustrates the operation of a basic photovoltaic cell, which is also called a solar cell. So solar cells are made of the same kinds of semiconductor materials such as silicon used in the microelectronics industry. So for solar cells, a thin semiconductor wafer is specially treated to form an electric field, positive on one side and of course negative on the other. When light energy, as you can see here, when light energy strikes the solar cell, electrons are knocked loose from the atoms in the semiconductor material. If electrical conductors are attached to the positive and negative side, so this is the positive and this is the negative side, forming an electrical circuit, and the electrons that are being captured in the form of an electric current. So that will produce electricity. This electricity can then be used to power a load such as light bulb, as you can see in this figure. Let's proceed. So solar cells. A number of solar cells electrically connected to each other and mounted in a support structure or frame is called a photovoltaic module. So as you can see here, here is an example of a module. Modules are designed to supply electricity at a certain voltage such as common 12-volt system. So the current produced is directly dependent on how much light strikes the module. So multiple modules can be wired together to form an array. So in general, the larger the area of a module or array, the more electricity that will be produce. So photovoltaic modules and arrays produce direct current or DC electricity. So they can also be connected in both series and parallel electrical arrangements to produce any required voltage and current combination. And now let's proceed to the example. An example of a power plant of 2 megawatts in which a large number of photovoltaics modules are connected in series. The 2 megawatts inverter can take input voltage from 600 volts to 900 volts. Determine the number of modules be connected in series to obtain a maximum power point voltage of 800 volts. Also, determine the power delivered by this PV array. The parameters of the single PV module are as follows. So, open circuit voltage or VOC is equal to 35 volts. Voltage at maximum power point or VM is equal to 29 volts. Short circuit current or ISC is equal to 7.2 amperes. Current at maximum power point or IM is 6.4 amperes. So the first step is we take note the voltage requirement of the PV array. So PV array open circuit voltage is not given and the PV array voltage at maximum power point is said to be 800 volts, right? Yes, right, 800 volts. So the second step is we should note the parameters of the PV module that is connected in the series string. So let's go back to the given again. So VOC is 35 volts, voltage at maximum power point is 29 volts, short circuit current is 7.2 amperes, and current at maximum power point is 6.4 amperes. So in getting the maximum power, we have PIV. So P sub M is equal to V sub M times I sub M. So we have 29 volts times 6.4 amperes will give us a maximum power of 185.6 watts. Next one, so the next step is to calculate the number of modules to be connected in series. So in order to compute for the number of modules to be connected in series, we are going to use the given of the voltage at the maximum power point or VMA over V sub M. So 800 volts over 29 volts is equal to 27.58. So we are going to have 27.58 number of modules. So we have to, since it has a decimal here, we have um, to get the higher integer value of 28. So the next step is, so since the higher integer value we got in the number of modules, the value of V sub MA and VOCA will also increase. So V sub MA is equal to V sub M times the number of modules. So from the given, so V sub M is 29 volts times the number of modules is 28. So it will give us 812 volts. So we have now the value of the V sub MA, so 812 volts. So lastly, to calculate the total power of the PV array, so we will just be needing the maximum power, which is 185.6 watts here, multiplied by the number of modules times 28. So we will get 5,196.8 watts. Thus, we need 28 photovoltaics modules to be connected in series, having a total power of 5,196.8 watts to obtain the desired maximum photovoltaics array voltage of 800 volts.
So the reference for these materials is by Near G 2021 How Do Photovoltaics Work? Again, thank you for watching and I hope you learned about photovoltaics.